Good morning, students. Today's good morning, students. Today's new topic in the subject. Good morning, students. Today we are going to read groups of metals, and in groups of metals, group one, the alkali metal. In the topic of Good morning, students. Today we are going to read groups of metals, and in groups of metal, group one, the alkali metals, in the topic of periodic table, in the subject of chemistry, O levels. So concentrate yourself. Here are a lot of concepts that will be involved. So concentrate yourself. We are going to start now. Group one, the alkali metals. So group one metals are called the alkali metals. So this is the first thing that you should remember. The elements with atomic number 1 greater than the noble gases accordingly are very similar. All elements in this group have one valence electron each. So this is the second point which you should remember, that in this group, group 1, every element is having one valence electron each. For example, here is the electronic configuration, and you can see at the end, in the last outermost shell, every element is having one valence electron. So lithium is 2,1, sodium is 2,8,1, potassium is 2,8,8,1. General physical properties of alkali metals. They are soft metallic solids with low densities. They are having low melting points and low boiling points. And they are very good electrical conductors, so it means electricity can pass through them easily. Okay, variation in physical properties down the group. So as you go down the group in group 1, so these are the properties which vary. Atomic radii increases, so as you go down, there are more electronic shells, so the atomic radii increases. Number 2, density increases. And number 3, melting point and boiling point decreases. So these are the properties as we go down in group 1. Okay, general chemical properties. They are very strong reducing agent, and they lose one electron readily to form a unipositive ion, because in the outermost shell there is only one electron, so they feel very comfortable in losing that electron and become a unipositive ions. Okay, variation in chemical properties as we go down the group. Reactivities increases, so they react more frequently as we go down the group. The reason is the atomic radii increases as we go down the group, so the attraction between the nucleus and the outermost shell becomes less, because of which the reactivity increase. So this is the reason. Ease of losing outermost electron increases with increasing atomic radius and decreasing nuclear attraction. So this is the reason. Reaction with water. Alkali metals react with cold water to form alkaline solutions and liberate hydrogen gas. And this is the general element of alkali metal. So 2M plus 2H2O forms 2MOH plus H2 plus energy. The reaction becomes more vigorous down the group. So as you go down the group, that's we have learned, the elements becomes more reactive. So as we go down the group, the reactions will be more vigorous with water. Next reaction is with chlorine. Chlorine reacts with heated alkali metals to form ionic chloride. General equation is 2M plus Cl2 forms 2MCl. The reactions become more vigorous down the groups. The same reason is there as we go down the group. So the atomic radii increases and the attraction between the nucleus and the outermost electron increases, uh, decreases. So attraction decreases. That's why the elements down the group are more reactive. So that's why the reaction is more vigorous. Next, chemical property is a reaction with air. Alkali metals burn readily in air to form basic oxides. The general equation is this one: 4M plus O2 forms 2M2O. The reaction gets more vigorous down the group. Same reason is applying again and again. Reaction with dilute acids. They react very vigorously, almost explosively with dilute acid. The general equation is here: 2M plus 2H plus forms 2M plus H2. Their oxides and hydroxides are basic and dissolve in water to give alkaline solutions. So this is the point to remember. Their oxides and hydroxides are basic, and when they dissolve in water to give alkaline solutions. Thus, they react with acids producing salt and water only because they are basic. So when they react with acids, they form salt and water. So this is another point to remember. When acid and base react with each other, the products are salt and water. Their chlorides and oxides are high melting point ionic solids. The elements in this first group does not have many uses as the metals themselves. They are too reactive because these metals are very reactive. As you are reading it again and again, they are very reactive metals. Because the reason is why they are reactive. The reason is they are having only one valence electron, due to which they are very ready. They are all time ready to lose that electron to form unique positive ions. So these are very reactive metals. That's why there are not much uses of the group 1 metals. For example, sodium. Sodium melts at 98 degrees C. Sodium is stored under oil. This keeps it away from oxygen and moisture in the air. Sodium can be cut with a knife. It's like cutting a piece of the cheese. So it is so soft metal. Now you will see why sodium and the other alkali metals are unusual metals. So here are some reasons. Because they are very unusual metals. They are very soft and corrode easily. This is the first reason. This question normally comes in the paper. You have to give 3-4 reasons why group 1 metals are unusual metals. So number 1 reason is they are very soft and corrode easily. Number 2, they have very low densities. Next, lithium, sodium and potassium float on the water. They are having very less densities, because of which they float on the water. Their liquid exist over a wide temperature range. That is, they have low melting and high boiling points. Their ionization energies are very low. This indicates that they are strongly electropositive, and they quickly tarnish in air but are shiny when freshly cut. So when they are freshly cut, they are shiny, but after some time, when they react with the moisture in the air, they become tarnished. They form very stable compounds. Look at the table. Can you see a pattern going down the groups? So lithium atomic number is 3, melting point is 180. Sodium 11, melting point 98. Potassium atomic number 19, melting point 63. Rubidium atomic number 37, melting point 39. And cesium atomic number is 55. So as you can see, as we go down the group, the atomic number increases and the melting point decreases. Typical metals have much higher melting point, but you can see at the melting point of the group 1 metals, they are having very low melting points as compared to the typical metals. The alkali metals are the most reactive metals of the metals in the periodic table. Group 1 elements are so reactive because it is easy for them to get rid of just one electron. They are too dangerous for you to use in the experiment because they are too reactive. So this is the reason they are, because too much reactive, that's why it is very difficult to handle them. Drop a piece of the lithium into a trough of the water, the gas will be given off and will be collected as shown. Test the gas with a lighted splint. Which gas is given off? It is hydrogen. So this is the paper 4 experiment. So when we put a piece of the lithium into a trough of water, they test the gas with a lighted splint, and it is a hydrogen gas. Now add a little universal indicator solution to the trough. Is the solution left acidic or basic? So the solution will become acidic. Okay. Now try sodium and potassium with water. You can see that sodium gets hot enough to melt itself as it reacts. Potassium gets so hot that it lights the hydrogen gas given off. It burns with a lilac flame. The periodic table is very useful. Its groups makes chemistry easier. You only have to learn the reactions of one element in a group. The others are usually similar, because if we know the reactions, chemical reactions and physical properties of any one element of any group, the rest of the elements will have almost the same properties. Compounds formed by group 1 metals are usually white solids that dissolve in water to form colorless solutions. The alkali metals get more reactive as you go down the group. So as you go down the group, the alkali metals will become more reactive. Okay, now we are going to read them one by one, their uses. Lithium. Lithium gets its name from the Greek word for stone. As the metal itself, we use it to strengthen other metals such as magnesium in alloys. So lithium is used to strengthen other metals in alloys. So this is one use. It is also used in batteries. Lithium batteries are powerful and lightweight because these metals are very lightweight. So that's why they are used in batteries, and because they are very durable, powerful and lightweight. They are suitable for calculators, watches and cameras for the same reason, because they are powerful metals and are lightweight. They are also used in the hard pacemaker. So because in the hard pacemaker in humans, because of this metal is very powerful and lightweight. So that's why this is used in pacemaker, hard pacemaker. Next is lithium compounds. Okay, look at the diagram below. Here are some uses of lithium compounds. For example, lithium compounds are used for killing germs. Lithium hypochlorite kills germs in swimming pool and in hospital laundries. So in swimming pool and in hospital laundries, they are used for killing the germs. Next is used in ceramics. Lithium oxide is added to ceramics from ovenware to the nose cones of the rocket. So because they are very strong metals, when they are used in with the other metals as alloys, they become very strong. So that's why they are used for in the ovenwares and in the nose cones of the rockets. Next is lithium compounds, as a lithium hydroxide helps to dye nylon and paper. Lithium compounds are used in air conditioning. Lithium hydroxide is used in air conditioning system and on submarine to remove carbon dioxide. Next use is lithium compounds are used in glass. Lithium carbonates is used in making tubes inside TVs and for lenses which darken in sunlight. So this is very important use. It is used in glasses. And Next, lithium compound is used in medicines. Lithium carbonate is used to treat mental illness. Okay, the next metal whose uses we are going to read is sodium. The element sodium is used in street lamps in nuclear reactors. Sodium compounds, the two most important sodium compounds are sodium chloride, that is the common salt, and sodium hydroxide. Okay, these are used as food additives. You will almost certainly find some sodium compounds in the list of ingredients, even if it's only salt. Common salt, sodium chloride NaCl was the first food additive that is used in daily life's food. Next is, nowadays we use many other sodium compounds as additives. Sodium sulfite, sodium nitrite, and sodium nitrate are all preservatives. So they preserve the food, they stop bacteria growing. So when they are mixed into the food preserve for a longer time. Other sodium compounds improve the texture of the compound. So when some sodium compounds are added into the food, the texture, the looks becomes very good. But perhaps the most well-known or infamous additive is monosodium glutamate. It brings out the flavor in food and is used a lot in Chinese restaurant. So whenever you go into the Chinese restaurant, a very familiar smell you can experience. That is the smell of the sodium glutamate. However, in some people, it can cause a dizziness, and this is the common experience whenever you go into the Chinese restaurant. The smell is very nice. That is the smell of the sodium glutamate. But when you are in a Chinese restaurant, the inside atmosphere make you dizzy. So you feel dizziness. So this is the thing. Headaches, nausea, and dangerous to asthmatics. Not surprisingly, it is banned from baby foods because of the same reasons. When that was added into the baby food, the babies become dizzy and they feel headache and they started weeping. So these are the reasons because of which it was banned from baby foods. Next is sodium carbonate. The material needed to make sodium carbonate are brine, sodium chloride, and limestone and ammonia. We make about 26 million tons each year. Look at the diagram showing its uses. So sodium carbonate's uses are here. Sodium carbonate is used in dyeing textiles. So the different colors are because of the sodium carbonate. These are used in washing powder and machines. It softens water. The next use is it is used in glass making, and it is used in sewage treatment. It neutralizes acid. So these are some uses of the sodium carbonate. Next, we are going to read the uses of the potassium compounds. Potassium is essential for the healthy growth of the plants. So when they are used with the soil, the growth of the plants becomes very good. Potassium nitrate is used as fertilizer. It is also used in making explosives and fireworks. So this was the lecture, students. Read this lecture again, understand it, learn it, and make your notes. Thank you so much.